All right, folks, welcome back to the Big Dog Podcast. And before we get started today, Lisa, today's episode is a special one. Do you know why?
I'm all ears, Jason. What's up?
Today marks our 50th podcast together. 50 sessions of bringing compressed air insights to the world together with the best co-host I know. If I haven't said it enough, Lisa, thanks again for doing this with me. I love this show.
Wow, 50 episodes? Kudos to you, Jason. You've been awesome this whole ride.
All right, on with the show. Lisa, you ready to talk about everyone's least favorite uninvited guest, water in your air system?
Absolutely, Jason. This is one topic that just does not quit. Water has a special knack for slipping into places it doesn't belong. So let's just get right into it. There are some big entry points we see again and again. First up, humidity and ambient air. That's the one nobody can dodge. Whether you're running a rotary screw or a centrifugal unit, that moisture is guaranteed to come along for the ride every time you compress air.
Yeah, and it's not just what's in the air. A ton of systems get burned by outdoor installs. Seriously, you leave a compressor out in the rain with barely a shed over it? I mean, I remember this plant out in Ohio, where they thought a little leak was nothing until a major downpour came through. Water got into an outdoor unit, and what could have been an afternoon fix wound up shutting them down for a full week. I'm talking a week of lost production, just because the outdoor weather wasn't handled right. That's avoidable pain.
You know what's overlooked too? Poor moisture separation, especially between stages in multi-stage compressors. If you skip or half-bake that step, water makes it downstream and sits in places you really do not want it, like aftercoolers, filters, sometimes even receivers. And then there's the hidden devil, cracked heat exchangers. If you've got failure in your water or air cooler, that can dump liquid water right into your airstream, or worse, the oil circuit. Not a fun fix.
Yeah, and a lot of maintenance crews still think, hey, as long as we dry the air, we're good. But dryers get overwhelmed, especially in high moisture situations or if the problem pops up after drying. So, Lisa, out of all these points, which one do you think gets missed the most on a plant walkthrough?
Ooh, good one. I'd say the cracked heat exchanger is the sneakiest. Maintenance folks are usually looking at outside air or checking their filters, but that internal failure just doesn't jump out until, everything starts rusting or breaking down. What about you? What do you think's the most persistent threat?
I gotta go with ambient humidity. You can't do anything about the weather, and if your intake is pulling humid air day after day, eventually you're fighting a losing battle unless you really dial in your separation and drainage. All right, let's roll right into what all this water actually does. Because just getting in is only the beginning of the nightmare.
Oh, totally. The damage water can cause. It's not just equipment failure. We're talking about rust, blockages, pressure loss, and even lines freezing up. I've seen rust flakes clog aftercoolers and tiny scavenger lines, and suddenly the whole system's backed up. Not to mention when stuff actually freezes, broken pipes, seals blown out, sensors going haywire. It's just chaos. And the filters and dryers get overloaded trying to keep up, so you're replacing them way more often.
Yup, and it goes deeper than blown hardware. Think about process quality. For example, I was in a shop where paint jobs turned out all bubbly and flaky. That was water blisters thanks to moisture in the air. Ruined an entire shipment. And sometimes it's not about what you see, it's the invisible bacteria and mold that water can help spread through your lines. Messes with pharmaceuticals, electronics, you name it.
Speaking of ruined batches, let's not forget food production. I remember a bakery had to toss out an entire day's worth of bread. All the buns contaminated because water made it through the compressed air, contaminated the product right on the production line. That is a punch to the gut, both for food safety and for the cost.
I think the worst hit I ever saw was at an electronics plant. Moisture got into the pneumatic system, shorted out sensors, and the finished boards got rejected over minute contamination no one caught in time. That's gotta be, $100,000 maybe? Easy. And a lot of times the operators just don't see the threat until half the system's compromised. It flies under the radar because symptoms don't show up until it's almost too late. What do you think's the reason water causes such sneaky problems, Lisa?
Part of it is, most people expect to see water dripping out if there's a problem, but it's usually hidden. like in valves, or it just hangs out in low points until it wreaks havoc. And with today's systems, compressed air goes everywhere, so contamination spreads before anyone spots a red flag. Plus, if your sensors get wet, suddenly you can't even trust the instrument readings. Honestly, by the time you notice the problem, the damage is usually done. Prevention really is everything here.
And that's a perfect lead into drains and how folks can get out in front of this stuff before it escalates. All right, drains. These are the unsung heroes. Or, well, sometimes the villains if they're not set up right. Most plants start out with time interval drains. That's the set it and forget it style. Opens at preset times whether there's any water or not. But here's the kicker, no water. You're just dumping air and money. Too much water and it can't keep up, so water piles up anyway. So then everyone starts fiddling with the timers, and before you know it, it's a guessing game on intervals.
Exactly. And then you end up with a float drain, or as some call it, the egg drain. This is a tiny bit smarter. Opens when water fills up to a certain level and closes after. Like the toilet tank float, right? Better than a time drain, especially if you don't want to babysit the system all day. But it can still get gunked up if you've got rust or sludge in the lines.
But here's where I always put my foot down. Zero loss drains. These are the gold standard. They use sensors, inductive, magnetic, whatever, to spot water buildup and drain it out without letting compressed air escape. That means you're not just saving air, you're saving cash every single cycle. Saw a plant lose tens of thousands of dollars on wasted air and ruined paint jobs before they switched over. After installing zero loss drains, problems practically disappeared. Look, yeah, it costs more up front, but when you do the math against ruined products or wasted energy, the ROI is a no-brainer for most places.
The big question I always get, how do you even know if your drains are doing their job? Honestly, it's daily checks or, even better, get a drain alarm. If you're not testing them or you're assuming everything is fine, you're setting yourself up for a nasty surprise down the line. It's one of those tiny investments in time or tech that pays back in a big way. Whether it's zero loss or just keeping an eye on your float, any neglect becomes expensive real quick.
Yeah, and don't underestimate working with a local pro. They know the local weather, your system quirks, and they can spot trouble way before it hits. So invest in smarter drains and keep someone accountable for checking them. I mean, that's just basic insurance for uptime. Anyway, Lisa, anything else people need to hear before we wrap?
I'd just say, don't be the plant stuck fighting the same water nightmare year after year. Take those preventive steps now, invest in the right drain tech for your setup, and if in doubt, call your local expert. They really can save your system and your budget in the long run.
All right, that's it for this round of the Big Dog Podcast. Thanks for hanging with us. Lisa, been a good one.
Definitely, Jason. We'll be back next time to tackle more of the tough stuff that keeps your plant moving. Take care, everybody.
Catch you all on the next episode. Later.